In the same way that before we have been comparing one thing to another using percents and converting them to a ratio out of 100, we're now going to talk about percent of change. So when we compare like the percent of the class that is boys, then we compare the boys to the total. If we're trying to figure out what percent of my wardrobe is dresses, then we would compare the dresses to the total amount of clothing in my closet. If I'm trying to find the percent of change, I'm comparing the change to something. And in this case, we compare it to the original. And here's why. Let's say that I have 2 bushels of apples. Bushel number 1 has 8 apples and bushel number 2 has 4. Now, if I'm adding 4 apples to each bushel, they're both changing by the same amount, but they're not both changing by the same ratio or the same percent. That's because when we're measuring the percent of change, we're comparing how much something changed by how much was originally there. Bushel number 1 changed by 4, but it was originally 8 apples. Bushel number 2 also changed by 4, but it was originally 4 apples. If we rewrite both of those ratios to be a percent out of 100, bushel number 1 changed by 50%, whereas bushel number 2 changed by 100% and had the greatest percent of change. This would be similar to the idea of making money. For you, as a kid, maybe you are making an allowance of $20 a week. So if someone upped your pay by $20 a week, that's a huge improvement for you in comparison to what you already had. Whereas if they up my pay by $20 a week, it's not going to make that much of a difference because of how much I get paid already in comparison. And since math always makes more sense when you see it, here's your first example. A sweater is marked down from $25 to $19. What was the percent of change? I always like to circle the thing we're trying to find the percent of. The original price of the sweater was $25 and the new price was $19. This means that it changed by $6. If we're calculating the percent change, we write the ratio of change compared to the original. It changed by 6 out of originally 25. Out of 100, that's a 24% change. Example number 2. To visit the top of the Empire State Building, a ticket costs $4 in 1999. In 2009, the price rose to $20. What was the percent of change? Originally, the ticket was $4. Now it's $20. So the change was $16. If I compare the change to the original, I end up with a larger number on top than I do on the bottom because it changed by $16 and it was only originally a $4 ticket. In the end, the ticket changed by 400%. Just to give you another visual that doesn't have to be copied in your notes, but might make a little more sense, is that the original ticket was $4. It grew to be $20, which means that you would have needed to add the exact same 100% of the ticket 4 additional times to have a total ticket, oh, that isn't ugly too, of $20. That's what it means to have changed by 400%. Example 3 is a different type of problem than 1 and 2. The 7th grade class experienced a 15% decrease in enrollment. Last year, the 7th grade class had 280 students. How many students are enrolled in the 7th grade class this year? Well, we know that the change over the original is giving us a percent out of 100. So let's substitute the values that we know. Well, they told us that the percent of change or the percent of decrease was 15%. So I already know that I need to substitute for my percent the 15. It also tells me that it originally had 280 students in that class. Now I'm going to use that ratio to figure out how many students that change was by. Like how many kids is 15% of kids out of 280. I know that 100 goes into 280 2 and 8/10 times. That means I need to multiply 15 by 2 and 8/10 to get my new amount, which is 42. This is telling us how much it changed. There were originally 280 students. They experienced a 42%, a 42% decrease, which leaves us with 238 students remaining in the class this year. Here's 2 problems for you to try on your own. Definitely don't need to copy them. Just try them in your notebook and play and check your answers. For number 1, there were originally 40 cars washed in a weekend. The new amount was 70, so that means it changed by 30. I convert 30 over 40, the change over the original, to a percent out of 100, and I get 75%. You could have done this with the ratio of seeing how many times 40 goes into 100 and multiplying the same thing, or you could have recognized that 30/40 simplifies to 3/4, which is 75%. For number 2, enrollment increased by 35% this year. Last year, there were 160 members in the PTA. How many PTA members are involved this year? 35 is a percent out of 100. I'm trying to figure out what that is out of 160. I see that 100 goes into 160, 1 and 6/10 times. When I multiply 35 by that number, I get 56. That is how many it increased by, which means I need to take the 160 it was originally, increase it by 56, and end up with 216 members.